This is Jacob's Algebra, Chapter 13, Lesson 7, the quadratic formula. So we've learned how to solve quadratic equations several different ways. We've learned how to put them in standard form and factor them to solve for our values for x. We've learned how to solve them by completing the square. And we've learned to solve them by taking the square root of both sides. Now we're going to learn another method called the quadratic formula. So remember that the standard form of a quadratic equation is, it went out of pen mode again, sorry, ax squared plus bx plus c equals 0. This is going to be the standard form of an equation where a is not equal to 0. So we can actually solve this by completing the square. So to complete the square, we need to have our x terms on one side and any constants on the other side. So I'm going to write this ax squared plus bx, and I'm going to subtract c from both sides to get equals negative c. Now I need to solve this by completing the square, but in order to do that, I want to have nothing in front of this x squared. I don't know what a is, and I don't want to have a square root inside of my inside of this. So I'm going to divide both sides of this equation by a. So I'm going to show dividing both sides by a. So what I'll end up with then is x squared plus b over a times x is equal to negative c over a. Now what I'm going to do is solve by completing the square. So I'm going to draw my parentheses with a square, take the square root of my first term, which is x, and then I'm going to take my second term and divide it by 2. That's bx over 2a. And then I'm going to divide it by this first term, which is x. So that will give me b over 2a. And then I'm going to write out what the square of all of this is. X, when we square it, is x squared. 2 times x times b over 2a is b over a times x. That's good. I should have the exact same thing I have up above. And now I need to square the last term, which is b squared over 4a squared. Now remember, when I square this term, I have to square the b and I have to square the a, but I also have to square this 2. So it's not b squared over 2a squared, it's b squared over 4a squared, because everything in this second term gets squared. And so I'm going to copy the minus c over a, and since I added b squared over 4a squared to the left side, I have to also add that to the right side, b squared over 4a squared. Okay, so now I need to put these into, I need to give these a common denominator so that I can add them together, because I can't add negative c over a and b squared over 4a squared. They don't have like denominators. So to get a common denominator, I need to multiply this first fraction by 4a over 4a. So I'm going to write times 4a over 4a. And what I will end up with is negative 4ac plus b squared over 4a squared. Now I don't like this having the negative term first, so I'm just going to swap the order and write b squared minus 4ac over 4a squared. Notice I didn't actually change what I have. I just changed the order of it. I wrote my b squared term first, the positive term, and then I wrote my negative term. Okay, so now what I can do is take the square root of both sides. I'm going to ignore this part in the middle, and I'm going to take the square root of the left side and the right side. When I take the square root of the left side, I get x plus b over 2a. When I take the square root of the right side, remember it's got to be plus or minus, and it's the square root of b squared minus 4ac over 4a squared. But 4a squared is a square, so I can pull it out of the square root and write plus or minus the square root of b squared minus 4ac, and this is over 2a, because the square root of 4 is 2, and the square root of a squared is a. Now, to get the x term by itself, I need to subtract a b over 2a from both sides. So I get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac, which is over 2a. Well, I have a common denominator here. That means I can combine these into one fraction. And so what I will end up with is x is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And in this case, our a is whatever coefficient is in front of the x squared. Our b is whatever coefficient is in front of the x. And our c is whatever constant we have. So this equation down here on the right, that is called the quadratic formula. And you can use this on any quadratic equation to solve it. But in order to use this formula to solve a quadratic equation, you must have your equation written in standard form. Okay, your book actually shows deriving this same formula, but I think the way that they do it is kind of convoluted. So I wanted to show what I think is a more straightforward method of getting to the quadratic formula. Okay, so let's see an example of how this works. What if we have the equation 5x squared plus 9x minus 2 equals 0? Well, the first thing we have to do is find our a, b, and c. So in order to solve any quadratic equation using the quadratic formula, first you need to put it in standard form, and that is making sure also that your powers are in descending order. So then the coefficient in front of your x squared, that's your a. The coefficient in front of your x is your b. And then your constant is c. Be sure that you remember that whatever sign is in front of your coefficient or your constant is also part of what you need to write down. So this is a minus 2, so I've got to write c equals negative 2. Not just the 2, I've got to grab the negative also. Now we can plug this into our quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You will use this formula throughout the rest of high school math and into college. So it's a very good idea to go ahead and memorize this formula. You will need it. You will use it. Okay, so now I'm going to plug in my values for a, b, and c. X equals negative b. Well, our b is 9, so negative b is negative 9. Then we have plus or minus the square root b squared. Well, our b is 9, so when we square that, we get 81. Minus 4ac. That's minus 4 times our a, which is 5, times our c, which is negative 2. All of that is over 2a. Well, our a is 5, so 2 times a is 10. Now what we need to look at is, what is this 4 times 5 times negative 2? Well, 4 times 5 is 20, times a negative 2 is negative 40, but we're subtracting it, so minus negative 40 means that we're adding 40. So what we actually have here is x is equal to negative 9 plus or minus the square root of 81 plus 40, and that's all over 10. What is 81 plus 40? That's 121. So this is negative 9 plus or minus the square root of 121 over 10. Oh, but 121 is a square number. The square root of 121 is 11. So we can actually write this as negative 9 plus or minus 11 over 10. So now let's see what these values actually are. X is equal to negative 9 plus 11, that's 2. So 2 over 10 is one answer. Negative 9 minus 11 is negative 20. So negative 20 over 10 is another answer. But both of these can be simplified. So I'm going to rewrite this. 2 over 10 is 1/5. Negative 20 over 10 is negative 2. So 1/5 and negative 2 are our two possible values, or are the two values that will solve this equation. Okay, let's look at some of the example problems in set 2 now. So in set 2, number 4 just asks for you to take each equation, write it in standard form, and then give the values of a, b, and c. So let's look at number 4, part C. What we're given is 7x squared is equal to x times x minus 3. Well, we can't write our a, b, and c yet because we aren't in standard form. So I'm going to copy the left side, 7x squared, and I need to multiply out this right side. X times x is x squared. X times negative 3 is negative 3x. Now to put this in standard form, I have to have everything on the left side and a 0 on the right side. So to get a 0 on the right side, I need to subtract x squared and add 3x. So I'm going to do that to my left side also. I'm going to subtract x squared. I'm going to add 3x. So what I'm going to end up with is 6x squared, because 7x squared minus x squared is 6x squared. And then I'm also going to have a plus 3x, and that will equal 0. Okay, now I can put this in. Now this is in standard form. It's in, my left side is in descending powers, and my right side is 0. So now I just need to give the values of a, b, and c. A, whoops, I slipped out of pen mode again, sorry. A, okay, let's try that again. A is the coefficient in front of our x squared. So the number in front of x squared is a 6. B is the coefficient in front of our x, so that's going to be a 3. And C is our constant. Well, there isn't one, so that must be 0. That's all that this problem is asking you to do. It is not asking you to solve anything. You just have to get the equation in standard form and then find your values of A, B, and C. So let's do another one. Let's look at part D. Part D is 3x minus 1 times x plus 5 is equal to x squared plus 6. Okay, now you can use a grid to multiply this out, and in fact I recommend that you use a grid if you have any issues with multiplying these out. I'm going to go ahead and just FOIL it. 3x times x is 3x squared. 3x times 5 is 15x. Negative 1 times x is negative x. And then negative 1 times 5 is negative 5. And that equals x squared plus 6. So on my left side, I have 3x squared plus 14x, because 15x minus x is 14x, minus 5 is equal to x squared plus 6. Now to get a 0 on the right-hand side, I'm going to need to subtract x squared, and I'm going to need to subtract 6. So I'm going to write minus x squared and minus 6, minus x squared and minus 6. So on the left side, I end up with 2x squared plus 14x minus 11, and then on the right side I just have 0. Now all that we have to do is write down our values for a, b, and c. A is the coefficient in front of our x squared, that's a 2. B is the coefficient in front of our x, that's 14. C is our constant, and our constant is negative 11. Make sure you grab whatever sign is in front of it. If the sign in front of it is a plus, you don't have to bother writing that down. But if it's a minus, that is attached to the number, because the plus is understood. When you don't write a sign in front of a number, it's understood to be positive. So that is all that number 4 is asking you to do, and that's just like number 11 that I assigned for homework. So let's take a look now at number 5. Okay, for number 5, we're given an equation, x squared minus 6x is equal to 12. And for part A, they asked for you to solve the equation by completing the square. So let's try doing that. When we're going to complete the square, we know we're going to write something inside of a square. We take the square root of our first term, that's x. And then we need to take our second term, cut it in half. Negative 6x divided by 2 is negative 3x. Then we divide it by this first term, so we're going to get negative 3. And now we square this out. X squared is x squared. 2 times x times negative 3 is negative 6x. And then negative 3 squared is 9. Okay, we just had a 12 here. We added a 9 to the left side, so we have to add a 9 to the right side. And so that gives us 21. We take the square root of both sides. We get x minus 3 equals plus or minus the square root of 21. Don't forget that plus or minus. So our x will equal 3 plus or minus the square root of 21. We will work on the rest of number 5 in the part 2 video. This is just part A, and we will finish it off in the part 2 video.